Hello and welcome to a demo here. This is Ryan Wallner from Portworx, and today we're going to be talking about PX security, specifically about how to enable multi-tenancy role-based access control for your Kubernetes cluster and volumes. So here we have a single Portworx cluster. It's on a 5-node, 3-master Kubernetes cluster here. And what I'm going to show you is how to set up your Portworx environment such that you can control the types of users based on namespaces or tenants or projects, depending on which Kubernetes scheduler you're using, to control how they can interact with persistent volume claims. So the first thing I want to show you is a definition of what a tenant is, right? So here we have, tenant A. It's got an email, kind of an identifier, a role. In this case, it's system.user. And this user is a Portworx default role saying that it is a user of the system and can interact with volumes. And then groups, depending on how you're organizing your users, where your users are coming from, you can identify different groups for them. So this is a definition of a single tenant A. Now tenant B we have here is similar, except the role is system.view. Again, this is a default role. You can create custom roles for Portworx and Kubernetes such that they have access to certain types of objects, but in this case system.view is a read-only user, so we kind of put them in a read-only group. Now within Portworx itself and Kubernetes, we can get the namespaces and grep for our tenants, right? So here we see that there's a namespace for tenant A and a namespace for tenant B. Now each one of these tenants has a token associated with them, right? So when you configure Portworx for PX security, you configure a token generator, an issuer, so to speak, and an admin creates tokens on behalf of a tenant. So down here, this terminal on the bottom right, you can see that interacting with the Portworx system, I'm acting as a admin. So as a storage admin, this is limited access to Portworx, and they're going to be the person that configures tokens on behalf of tenants in your Kubernetes system. So as a storage admin, I've gone ahead and created tokens for tenant A and tenant B based on the roles identified on these files on the left. So tenant A has a system.user based role and a token that associates that, and tenant B has a system.view token that associates that. So if we look here in Kubernetes, we can get the secrets, and specifically for our namespace, and here we can see a Kubernetes user. So as an admin, I've gone ahead and created this Kubernetes user, and this holds the token for the tenant, right? So if I look in tenant B, they'll also have a Kubernetes user token. Now I control these as the admin, right? So if I need to rotate them, I can go ahead and refresh the token. And tokens have a different level of expiration, so if I set an expiration, I can refresh them when needed. But the point is, the user doesn't really have to interact or control their token. The request is verified based on their role from an abstracted view. So how does this actually get used? If we look at the storage classes available to us as a user, right, we can see there's a Portworx storage class. And if we go ahead and get this storage class and look at the YAML, we can see here that there's a number of different defining parameters that define how it gets the secret and from what namespace. So from my namespace in a certain tenant or project, it's going to automatically look up my token and see if I can use the token to make the request I'm trying. So let's take a look at an example of a PVC, right? So here, if we look at the PVC definition for tenant B, all it does is say, I'm going to use the PX storage class to try to create a volume, right? Now remember, this was a read-only user, so in theory, this user shouldn't be able to create this volume. So let's go ahead and create that. Now, if we take a look at our PVCs, again, you have to specify the tenant that we're looking at. So it's tenant B. Here we can see that my PVC is pending, and we can go ahead and describe this PVC. Now, what you'll see here is a permissions denied description. So it's saying that access to the open storage volume create was denied because you have the system.view role, right? So this is the expected behavior, saying that just because I'm a tenant within Kubernetes, I am not necessarily allowed to create volumes through Portworx, even if I can create the YAML object to do so. Now, if we wanted to do the same thing as a different tenant, right? So let's go ahead and create the tenant A PVC, and we'll take a look at the PVCs within tenant A. We can see that now this one's bound, right? So if we go ahead and describe the PVCs in the A namespace, this one had no problem describing that, right? Because remember, tenant B is a view-only user, and tenant A is a system.user, part of a developers group. So they should be allowed to create volumes. So this is kind of the general idea here. And if we look here, we can actually see the volume within Portworx created, no problem. It's detached because Pod's not using it yet. But the idea here is that you can, as an admin of Kubernetes, put your groups of individuals or developers into different tenants within different namespaces or projects, and assign them roles and tie that role to a token, which Portworx understands and can limit the ownership and role that they play with storage. Hope this makes sense. Hope it was useful. Until next time, take care.